So this is Autodesk Inventor, which is a 3D CAD program. So we needed a model to put inside of Unity, and a 3D model of the PiCar didn't exist. So this was a pretty rough mock-up that was created. So you can see that we've got the top platform. Doesn't have the spoiler on it, but it's the basic shape and the correct dimensions. We've got the bottom one. The wheels were created kind of from scratch to look roughly like the ones on the vehicle. Same thing with the tires. Now, some of these components were available for download. So for example, this is an IMU we're using called the B&O 055. There was a CAD model for that. This is the 18650 battery. This is the Raspberry Pi 4B. You can see as I click them, they're selecting on the side. This is a servo that controls the ultrasonic sensor, and that was broken out separately. And there's also the camera module. So here you can see where we installed the camera module. And the ultrasonic sensor was actually created as a separate... That was created as a separate assembly, and the reason that was done separately is so that we could animate it inside of Unity, just to give you an idea of what that looks like. So this is kind of a rough shape, but this way it's a separate, what we call game object in Unity, and that'll be shown in a separate video, and that way this can be animated inside of Unity. Okay, this video is going to be a quick walkthrough of Unity. So Unity is a general 3D development environment. It's typically used for game development, although it can be used for kind of any kind of 3D visualization environment or even 2D. It allows the binary exported to be either a PC desktop application or Android, iOS, or PS4, Xbox, etc. So it allows a lot of different sort of write once export to a lot of environments. So what we're going to do here is I'll walk through a few basics. So the first thing we needed to be able to have a 3D model of the car. We wanted something that would animate on screen as the physical car moved and we received that data. We needed a way to represent that inside of Unity. So in the previous video, you'll see there was a 3D model was made of the car inside of AutoCAD. Inside of Autodesk Inventor. This was exported out as an OBJ file, and it was imported into Unity. And then so if I click on the car, so when it was imported, we had this PiCar 4, which is all of the different, you can see all the different pieces, every individual mesh for this is all represented in here. So you can see the wheel, and then what you'll notice here on some of these, because when it comes in, there's no colors applied to it. So inside of shader, this is where we actually come in and we can apply different textures, colors, what we call materials to it. So we create a material, and then we can apply that to the individual ones. And this way we can give it a little bit of color. Separately, the ultrasonic sensor is a second object in here that was imported. And this way, you can see, this way we can animate this object separate from the car. So if you see rotation in the upper right here, as I move that, I can put in, for example, let's put in 90. You can see that we can rotate it 90 degrees, 0 degrees, or -90, or some value in between. So what we're going to do is we're going to be subscribing to data from the sensors, importing that into Unity, and then we're going to be able to move the car around with this information. Another one is the IMU data. And what the IMU data is going to do is it's going to allow us to get the rotation of the whole car. So if I click on the full car object, and again I go here, I can rotate the entire car. Again, I'm doing it manually, but this will be done programmatically. So you can see I'm rotating it here. And we're just basically mapping. We get that heading value from the IMU, and then we're going to enter it into here. The other data we're going to get is going to be the encoder data. So this is going to be as the wheels turn, we're going to get that encoder information, and we're going to use that to physically move the entire car. So instead of a rotation, we're going to be able to move the position of it. So let me see which one moves the car. Okay, so Y is up and down. So we're going to be moving it in the X direction and in the Z direction. So right now we're in what's called the scene view. So if I use my scroll wheel, I can scroll in and out. If I hold my right mouse button, I can kind of pan around the scene. If I click and hold my scroll wheel, I can drag the scene around. So this is so we can lay out our objects in the scene. So you can see we have these different objects in here. We have our car. We also have something here which is the plane. So that is simply the 3D, this is just the plane that the car drives on. Game object, 3D objects, and we create a plane. In that plane, you'll see there's an element here, concrete pattern. So concrete pattern is a material that was applied to it, and this allows us to just put a material or a texture, you can see. And there's a number of these that can be downloaded from the Unity Asset Store. Up here, we go to Asset Store, and we can come in here, we can search for different materials. I searched for one called concrete, and then was able to apply that to this surface. There's also lighting in here. You can see there's directional lights. There's the ability to put in cameras. Now, there's another thing in here called a canvas. A canvas is if you want to put a 2D user interface that lays over the 3D environment. So we're in this scene view right now. If I scroll out, this is a bit unintuitive, the way it does the canvas, because this isn't how it looks in the game. But when you want to lay out your canvas, which is where you would put buttons, this is how it's represented. So we create a canvas, so game object, we would say UI, and then we would do canvas. Once we have our canvas, then we would do game object UI, and we would put text, buttons, things along those lines we would drop onto it. And if you see, this is actually a 2D. So if I kind of scroll to the side, you can see how this is a 2D system, or a 2D visualization for the UI. And this overlays on the game. So if we go to game, see how we're in the game view? The game view shows us what the virtual camera is seeing, plus it shows us the UI overlaid on top of it, if the UI is enabled. So we can go to canvas. If I unclick canvas and I go back to this game, the game isn't running right now, but this just shows us in a static view what the game would look like. So again, I could turn on canvas, it turns these on. You can see there's a forward button. Well, if I uncheck forward, that button disappears. So this kind of leads into the UI functionality. So we put this button in here. So we go canvas, or UI, and we say button. We drop this button onto the scene. So now we have a forward button. And this is the text. So if I click this forward that's under forward, this gives me the ability to change the displayed text. So if I put 1, 2, 3 after it, you see it show up right there. I can change the font, the size, etc. of that. But let's go back to the button. Well, what we want is we want the button to actually do something. So we have this down here. I'm going to go ahead and set this up because I think this looks like this might not have been set up for some reason. So what we're going to do is we're going to do on-click, editor and runtime, and we need to tell it, well, what do we want to happen when forward is clicked? I'm going to grab my scripts folder, and I'll explain that one in a minute. We're going to drag it over here to object. So now it's going to look inside of my scripts folder. So we'll just click over to that. This is where I have a bunch of our scripts running. This is C# files. And we're going to, inside of one of these, there is a function call that we want called in order to move the car. I think that's inside of this ROS script. So we're going to go back here. We're going to say function, ROS, and we're going to say move forward. So there is a move forward method. And if someone clicks forward, it's going to call move forward. So same thing, we're going to drag our scripts here. We're going to choose ROS, and we're going to say we want to move backward. We'll just do these other two. We'll do the other ones here while we're at it. Again, left, we're going to take scripts. It's a good idea to just put your scripts inside of this game, one of these empty game objects. You can just do game object, create empty. It's kind of like a folder. And in this way, we're not dragging the actual script into here. We're dragging that game object with the scripts embedded into it. Okay, so we're going to do ROS. We're going to say move right. And we're going to go to stop. And move stop. So now we have all these set up. Make sure we save our scene. Save our project. A couple other things that are in here. We have VLC, which is a library for doing streaming video, so that we can import streaming video into it. And what I'm using here is, you can see it's, let's get back to the scene view. So we have this VLC 360 is, actually let me undo that. Actually, I think we're not using that. It's raw image. So what raw image does is, this is actually going to take the image from VLC. It's going to take that image and it's going to display it into this raw image, and I can do a separate video on kind of how that works. And then you can see the other things that are set up inside of this UI. So we've got CPU, GPU voltage. We've got all these other things. Same thing. I can see video toggle. If I press that, it's going to run this thing called toggle video, which is simply going to turn this video on and off. So if I click game, it's going to turn this on and off. So I'm going to go ahead and do a separate video getting into some of the code. So this is just a good first overview of the Unity, the actual Unity environment, how things are placed in the environment, and how we can sort of make changes to them. All right, so this is Unity part 2, and I want to get into some of the code on this one and see how we can, how the code interacts with the UI. So we're going to scripts. So you can go to add component, and you can type new script, and you can just type in the name for new script. That'll create a .cs file. So we'll start here with the ROS one. So open this up, double click this. This is going to open it up in Visual Studio. So you'll see this is mostly pretty standard C# with Unity's additional library available into it, to where you can interact with physics and game objects and audio and all these other things. So this will give you a basic idea of how we're doing this. So there is a module called WebSocket. And I'm going to click back over just to show the asset store real quick. So if we come in here to asset store, so WebSocket, you can see there are modules that you can, some of you can buy, some of them are free. So what I did here is I got one of the WebSocket modules, and what it does is it just creates a, it just makes it a bit easier to talk to WebSocket. There are any type of C# library should be fine for that. So what we're doing here is basically we create this WebSocket connection, and that connection is connecting over to ROS. And on ROS, what we have running is this thing called ROS Bridge, which is documented elsewhere. And what it does is it is publishing on port 9090 on the actual PiCar a WebSocket interface to ROS. And ROS is what we're using for accessing all the sensor data. So if we want to read the IMU, if we want to send a command to the motors, read the encoders, get data from the ultrasonic sensor, all that data is inside of ROS. And what this does is this just gives us a bridge to where we can get to it from a WebSocket connection. So what we're basically doing here is we're creating this new WebSocket connection. And one thing you'll notice here in Unity, which is interesting, is when you create a public variable, so you'll see one here called public string RPI URL. And if we come back over here to ROS, We go into scene. You'll see it right here, RPI underscore URL. So this lets you define a variable or an object from this side and connect it over to the code. So now whatever's entered in here, which is my address to the Raspberry Pi, it could be an IP address or whatever, is now available in here. So when I connect to the WebSocket, you can see we're feeding it that public variable. So if you looked at this normally, you'd be like, well, this string is undefined. How is this able to read an undefined string? It's because that information is getting passed over from Unity into here. So we can just say that's passed from the Unity interface. So what this is doing, this is basically, this WebSocket is an event. So anytime a new message comes in, so basically this is saying is on open, call the on open ROS function or method. Anytime we receive a message, we're going to call on message handler. Anytime we get a message, an error, we want to call this. So if we go to on open ROS, we're passing it that WebSocket. And what we're doing is we're going to send it a JSON string. And this JSON string is going to tell it that we want to subscribe to certain topics. So if we come back over here to ROS, I'm going to restart this one. So what we're going to do here is I want the data for the IMU, and I want that data to be sent into Unity. So if I say ROS run, PiCar, IMU pub, what this is going to do is this is going to connect to our IMU. It's going to run this Python script that reads data from the IMU and it publishes it out to ROS. So now if I say ROS topic echo, say ROS topic list, this will list all the topics that are being published. So we can see on a ROS topic echo, we have one we created called orientation. And this is publishing the IMU data. I'm going to physically rotate the car. So what you can't see is with my left hand here, I'm rotating the car like this on my desk. And as I do, that heading Z is the heading for it. All right, so we can see that there. So I'm just going to stop that. So what we're doing over here is I'm saying I want to subscribe to the topic / orientation. And the message type is called PiCar orientation. PiCar orientation. This is it will be in a separate video on ROS, but you can see if we have one called orientation.message. It's basically an XYZ floats. So again, if I do this, you can see we've got our header information, which is the timing of the module of each packet, and then you can see the actual XYZ values. Okay. So let's come back here. And then we're doing this for the encoder, for the ultrasonic sensor, and the health publisher. So we're basically just doing it, and then we're saying send. So we're going to send this from Unity back into the WebSocket server, and that WebSocket server running in here. So if we say ROS node list, ROS bridge WebSocket is listening for these messages. As soon as we do this, it's now going to start sending, it's immediately going to start sending these packets of this data. And that's going to send it, and it's going to get received on message handler ROS. Every time that runs, we pass it the WebSocket, and it's going to take the string, which is going to be JSON data coming from ROS over the WebSocket, and then we're going to parse it. So this is using a JSON library that you can download. You can download it. I think it's a C# package, and called Newtonsoft JSON link. And what we're going to basically do is we're going to parse that data. So now I'm parsing the message. So it's all the messages. It doesn't matter the topic. They're all going to get sent into here. So now we're going to parse it. We're going to parse it as encoder, orientation, range, health pub. If you wanted to do a new sensor, let's say you wanted a laser scanner, you want something else, you could publish that into here. Another one that we're going to probably end up creating in here, just haven't done yet, but I can create one called, that is called camera, I think. Let me see, I've got one called camera. So what camera is, or that's the topic. So if we just come back in here, Ross run PiCar camera. This is going to actually take our RGB camera and it's going to run it through TensorFlow and it's going to look for somebody in front of it. So actually let's stop that and restart it in the background. And now if I do Ross topic list, sorry, Ross topic echo camera OBJ. And now if I put my hand in front of this thing, sometimes it'll pick up my face. Yeah, so you can see it said person. So it's basically it's either going to be null or it's going to be person. So I can take that and it's camera OBJ. And what we're going to do is we're going to then create a new and all this is going to do is this is just going to call another method in another script that hasn't been created yet, and that's going to do something else. Maybe on the UI we say person detected and we display that up on the UI, something like that. Okay, so pretty straightforward. And then I'll just show you kind of basically how we do the encoder. We'll just look at that one script. So if we right click, go to definition, we open up this process Ross message. So this is, we'll go back into Unity. We've got our encoder script. And you see we have this object called car. So if you look here, we have public game object, car, and then here is where I'm actually telling it which one. Well, if I click it, on the right, you see over on the left-hand side, it highlighted the actual car. And you can see if we just kind of drag this over. So what I'm doing is I'm creating this variable, and then I'm associating it with the physical car. So that's how I create that connection. So this is the 3D model of the car in Unity. Awake means anytime this script is started, it just runs the awake one time. So we also have this process Ross message, which if you remember from here, that's getting called. So we call that. Now we're not actually passing it anything, the encoder. We could pass it, you'll see the other scripts we pass it the actual message. Here we don't pass it because if we receive encoder, we don't even care what the value is because it doesn't tell us what direction the motor's facing. If we want to know which motor is moving, we could pass that information in. But for us, we're not differentiating between one motor and the other. So we just basically say if a message for encoder is sent, good enough. We don't need to know more than that. So when that happens, so we have a float. And what we're doing is we're reading something that Unity has called car. So car is our game object. So again, if I just sort of do, just to give you an idea of the code complete, if we just type in car dot, it's going to give us what are all the available commands that we could do, or all the methods or things that we could call on this car game object. So we could say car dot, and what we did here is say car dot transform dot position tab dot, and you can see here it's going to give us our so instead of position, which we want to know the XYZ position, just to give you an idea, you could also do rotation, and you could say rotation dot, and you could get the Y rotation of the car if you wanted to get that. So we're reading the XYZ position of the car, and then what we're doing is we're saying translate transform.forward, and we're going to have it move 0.5, and that's going to be how much the car moves forward inside of Unity. So for each individual encoder step, we basically figured out that each encoder step is going to be equal to like 0.5 inside of Unity. So what that does is it's going to... Now, what's nice with this forward command, and I'll show you the difference here. Okay. When you make a change to the script and you come back to Unity, it'll hourglass you as it kind of recompiles. So hopefully it's doing that and not actually going to lock up on us. All right, well, that might have locked up. But now the other possibility here is if we didn't use this translate, the simpler version is if we say transform.position equals new vector 3, and then here I could actually give it a new position. I could give it a specific position. So, oh yeah, I remember. We actually aren't using these anymore because the original way I was going to do this is to read the current position of the car and then increment that. But because the car could be facing in any direction, if it's faced diagonal and you increment, you might be moving the car forward diagonally. And I wanted it to just move forward on its current trajectory. Again, if you wanted to compute it, you're going to have to run the trigonometry in order to figure out like what x and y value do I want based upon my current orientation. That starts to get complex. Now you're having to read the current position, the current orientation. Unity just gives you this nice thing that says, well, whatever direction you're in, just move forward by this 0.5, and it just simply moves the model forward. So, all right, let's see if we're still, well, we might be frozen up here. Well, I think this is good enough for this video for now.